Good morning and welcome to your Friday lesson. This is just a little video walkthrough to help you get through today's independent practice. Your Nearpod lesson is waiting for you in our classroom, but I wanted to help you get through a certain segment of the activity today, which involves using Amplify and its simulation for plate motion. So let's kind of get started. In your lesson, you're going to have a few questions, announcements, things that you need to get to. I'm forwarding to the portion where you'll need to get onto Amplify. So when we get to here, you're going to watch a nice little video that shows what the Earth's outer layer looks like underneath the oceans. If you were to remove all of the ocean's water from the planet, what the underneath the surface would look like. So the ocean floor, what would it look like? After you hit that, it's going to take you to a little lesson here on this simulator that you'll find in Amplify. Now, there will be links later on in the presentation that you can click on that will let you play with Amplify's simulator, but I will kind of walk you through it. So this here is an image of a Earth-like planet. This is not Earth. Obviously, if you look at the different land masses and continents that are visible, none of them really match up with anything that we have on Earth as we know it. So it's supposed to be a simulation of an Earth-like planet that has the same composition and systems that Earth does. For the simulation, what you're going to do is, this is like the home screen of the simulation. It's going to ask you to do a few different things, but first off, just kind of get you familiar with the views of what you're looking at. This is the top-down view. So imagine if you're looking from an aircraft looking down at the surface of this planet. What you're looking at here in the blue would be water. This little green line that's running down the middle is what we consider a plate boundary. And again, you can see over here it says plate boundary. You can select where you want it to put it and what type you want. But the idea being that this is where two pieces of the hard solid rock beneath the oceans and land actually meet. So this is kind of like those two puzzle pieces of hard solid rock where they meet. This is their border. So they are not joined here. They're just being pushed together around this area. This view here is a cross-section view. Remember, we talked about cross-sections yesterday, where we specifically said that a cross-section is something that shows you what the inside of a solid looks like. So we did a couple comparisons. We showed, excuse me, we showed an apple when we sliced an apple in half, and you were able to see the very, very, very thin skin of an apple that surrounds the fruit, that surrounds the core, that surrounds the seeds. So this is the top-down view of the planet. So all we can really see is water, and then we have this highlighted plate boundary line. If we were to look at this from the other angle, instead of top-down, we're looking at it from bottom to top on a side view. Here we have atmosphere, the light blue. Here we have water. Here we have crust, or this is what we call the outer layer, the hard solid rock. And then underneath it, we have the soft solid rock, which is known as the mantle. That is the layer that is beneath Earth's outer layer. Up at the top, you'll see that we have some toggle switches and things that you'll be using in today's simulator. Here you can turn on and off the surface of the planet, so remove water, have water. Over here, you have a couple drawing tools. You're actually able to create new rock. You're able to build like land formations or continents by clicking and drawing. Over here, you have markers, which you're able to drop along either side of the boundaries. And what that basically means is you're going to be able to use those markers to visualize if the plates are actually moving or are they stationary. And then the set boundary line is what will let you actually set what type of a plate boundary line this is. So you can see how that boundary line of the two things meet right here. That's that. And then finally, in the very bottom, you have this little adjusting toggle that can let you go change the composition of the mantle from being a hard, solid rock substance all the way over to the right to being a soft, solid rock substance. Now, this color indicates heat as well. So the hard, solid rock is mostly cool, and then the soft solid, to make rock soft and solid, typically it needs to be heated to a certain degree. So it's obviously hotter on this end than it is on this end. All right, that kind of takes you through what the simulation looks like. In your lesson, you'll actually have a little bit of a breakdown of the toggle switches and tools, so you just kind of, you know, think about what those tools do. On this screen here, when you click on this, this will actually take you to Amplify, so you'll actually be able to do the lesson. I'm going to go ahead and cheat and take you over to where it is. Here are the, let me skip over because I think I actually included the instructions for the Amplify thing here. So yes, so once you get the plate simulation open, or the Amplify open, you've got a few steps that you need to follow. So you can always refer back to this chart here on your Nearpod lesson. So just have that open on one side, and then you'll have your Amplify open on the other. So this is that simulation we were talking about. It says we can play with either sections 1 or 2 of this Earth-like planet. So for right now, I'm just going to go ahead and click on section 2. As you can see, there is no visible land formation on either side of this plate boundary. This is the plate boundary. Over here, this is the location of where the cross-section view was taken. So I can actually move that cross-section anywhere along this fault line. And you can see in the bottom cross-section view, you can see my angle of viewing at it is shifting from right to left. All right, so let's go back to our instructions, and we will show you what that instructions are for that simulation. So our first instruction basically tells us to open up the simulator. All right, so let's go do that. So we go to the simulator, and there we are. Our next instruction says, select region 2, use the add rock tool to add continents to the map. All right, so that's what I'm going to do next. I'm going to use the add rock tool, so that way I can point and I can actually start drawing some land on this side. Now notice what's happening here when I'm drawing land. On the cross-section view, the crust, or the outer layer, starts to get thicker, right? All I'm doing is building hard solid rock on top of hard solid rock. And the reason why we can see this land is because it's actually made the outer layer thicker than the water. So what we're doing is we're actually just increasing the amount, and we're displacing the water to other locations. So where on this side of the map we used to only have ocean on this side, now we have land, and we've actually created a new little area over here that is completely surrounded by water, a new little island, if you will. And I can do that on both sides of the map. I'm going to go ahead and just put some land over here so you can kind of see what we're doing. Our next instruction says, press set boundary to select the boundary type. You can always return and build to see what happens if you select different types of boundaries after you make your observations. Okay, so we haven't talked too much about the types of boundary lines, but we definitely have talked about a boundary line is where two plates, two hard, solid pieces of rock that can make up the outer layer meet. And it looks like you've got two different choices. One's called divergent, and one is called convergent. Notice the arrows in relationship to the plate boundary line in between. Divergent shows arrows going away from the plate boundary line. They're like running away from each other. And on the convergent choice, we have boundaries that are running towards each other. All right, so I'm going to pick convergent. Notice how that automatically just changed our cross-section view. It looks like here, the continent that we've created, the land mass that we've created on the right, is actually dipping and going down into the mantle. You'll notice that hard solid rock here is angling now, and it's actually dipping back down into the mantle. So let's go ahead and see now what our last instruction would be. That last instruction is press run and observe how the cross-section view changes. That's the lower view of the screen as you run the sim. You may want to press reset at the top to replay the sim that you've chosen. So here we go, moment of truth. Let's see what happens when we have two continents that are joined at a convergent boundary. We watch that cross-section view, and we watch that upper view, but mostly down here, watch and see how this changes. So we'll go up to the very top, select run, and that's the end of the simulation. So what you're going to do today in your activity is you're going to do this a few times, and you're going to be asked to basically do this multiple times using different boundaries, different land formations, and record your findings. Is there movement that's happening? What are you seeing? Can you describe what you're seeing in the cross-section view? All right, that is something that you're going to be focusing on. So you're going to be asked to put together some sentences. You're going to learn a little bit more about what continents are versus just the outer layer, and we'll go from there. So please go ahead and work your way through today's lesson. There will be a quiz at the end and an exit ticket that you need to answer for credit. So please take your time in doing so. I hope you found this video helpful. Can't wait to see you all on Monday. So have yourselves a solid last Friday of school, and I will see you on Monday.